Hello everyone, I, Mr. Siddesh Vilas Darade, working as Assistant Professor in SVKT College, Devdali Camp, Department of Physics. Okay. Today we are going to learn a subject name is laser. Okay. This lecture is made for the course of B.Sc Physics for the semester 6. Okay. For study this subject, we know the importance of that subject. Okay. Let us start the importance of the subject. Okay. In this subject, we are going to learn one of the application of light phenomena. As we know, light has a dual nature. One is wave nature and other is particle nature. It has various applications. According to it, laser is one of its application on the basis of optical phenomenon. We know that nowadays laser are used in medicine for laser surgery and various skin treatment. In industry for the cutting and welding materials. They are used in military and law enforcement devices for marking targets and measuring range and speed. Later on in this we are going to see the session agenda. What we have to study in this lecture is the brief history of laser, later on ordinary light and laser. After that we are going to study the interaction of radiation with matter. That means how the radiation interacts with the matter and what are the significances it produces with the interaction of matter. Okay. Let us start our first topic, brief history of laser. Okay. Laser is acronym for light amplification by stimulated emission of radiation. In 19th century, Max Planck published a work that provided the understanding that light is a form of electromagnetic radiation. In 1970, Albert Einstein described the theory of stimulated emission. He postulated that when the population inversion exists between upper and lower level among the atomic system, it is possible to release amplification stimulated radiation. After that, in 1951, Charles H. Towne and his co-worker independently investigated and suggested the principle of measure based on the stimulated emission at Columbia University. According to this stimulated emission, okay, they are construct the measure, and measure stands for the microwave amplification of stimulated emission of radiation, which is a device that amplifies the microwave. It is a device that amplifies the microwave in immediate application in the microwave communication systems. Okay. On the basis of stimulated emission principle, later Theodore Maimin on 16 May 1960 was invented the first working laser based on ruby crystal as a lasing medium. Later on, in December 1960, Ali Jawan and his co-workers invented first helium neon laser at Bell Laboratory. After that, various kind of lasers are discovered, such as solid-state laser, gas lasers, and their application widely usable in day-to-day life. Okay. After the brief history, we are going to move our next topic, that is the difference between ordinary light and laser light. That means how the ordinary light behaves and how the laser light is behave. As we know, the ordinary light is flows in terms of energy, that means in the form of wavelength, that it is known as the photon in the form of photon. Okay. The main difference between these can be characterized on their characteristics. Okay, can be evaluated, differentiate these, the ordinary light and laser light, on the basis of their characteristics. There are mainly the four characteristics of the ordinary light, such is the chromativity of light, that means directional, other is direction of that light, other is coherence of that light, another one is we consider that the intensity of light. In terms of these characteristics, we can differentiate ordinary light and laser light. Okay, the first is the chromativity. The ordinary light is polychromatic, means it consists of colors of light, various colors of light in the wavelength of 400 to 700 nanometer, whereas the laser light is monochromatic, that means the radiation of the light consists by the laser is one, that means it consists only one wavelength. Other is the difference between laser and ordinary light is the ordinary light is unpolarized, that means the radiations of the ordinary light is oscillating in all directions, whereas the laser light is polarized, that means the all radiations are oscillating in one direction, hence highly directional, laser is highly directional. Other difference is the ordinary light is incoherent, that means the frequencies are merged up to a given and intermediate between the maximum and minimum frequency, whereas the laser light is coherent, it containing single frequency with the maximum amplitude and can be focused to very small spot, that means it can be focused a small part. Therefore, it is used in medicine for the focusing to the cell of human body. It can be differentiate or cut the laser body due to this property of laser. Okay. On the other hand, the intensity of ordinary light is decreases with distance as it travels in the form of short pulse of small length and short direction, whereas the laser light travels in only one direction, which is parallel to the optic axis, hence the laser light is highly intense. As we seen in the diagram, laser differs from the ordinary light, that is the first property is monochromatic, that means the laser light consists only one green color light, whereas the ordinary light has different colors. Therefore, in next the direction of the laser light is one directional, that means is unidirectional, whereas the ordinary light has the direction in polydirection, therefore it is differentiate in many directions. Other is the coherence, that means the wavelength is single of laser light, and ordinary light consists of various wavelengths. Okay. On the next topic, from this we can conclude or we can characterize laser as laser is highly direction. Okay. Another is laser has the monochromatic. Okay. Other is laser is polarized, and other is it has high intensity. These are the four characteristics of laser. That means laser have the four characteristics, that is first is highly directionality, okay, other is monochromativity, third is polarized, and fourth is high intensity. Okay. After that, we are going to learn our next topic is interaction of radiation with matter. As we know, light travels in the form of photons. So, if it is bombarded in any matter, okay, there are something is happen in between them. As we stated that, as we know that light has a dual nature. First is a wave nature, other is particle nature. The particle nature consists the interaction with the matter. Therefore, we know the Max Planck. We know that the Max Planck publishes that the light is a form of electromagnetic radiation. Therefore, the interaction of electromagnetic radiation with the matter produces absorption and spontaneous emission. Okay. The absorption and the spontaneous emission are the natural phenomena. Okay. For the generation of laser, stimulated emission is essential. That means for the production of laser, the stimulated emission is essential and is generated under special condition as stated by the Einstein. Absorption of electromagnetic radiation is the way in which the energy of photon is taken up by matter. That means in the form light travels in the form of photon, and it consists of energy which is the energy of photon is taken by a matter. That means any radiation is heated on the matter. Interaction of radiation, the radiation is heated with the matter, and the matter is gain the energy of that radiated or that radiation, and the reduction in the intensity of light wave propagating through a medium by absorption of a part of its photon is often called attenuation. The frequency and the wavelength of light are related to the velocity of light c by the relation, as we know that the c is equal to v lambda. Okay. After that, when a beam of light passes through absorbing medium, then the attenuation of the light in the medium decreases with decrease in intensity of light. That means the intensity of light is decreases with the decrease in intensity, which is proportional to the intensity of light and thickness of medium. Okay. Therefore, the di is equal to, in the expression form, di is equal to minus alpha I dx, where alpha is a coefficient of absorption and the negative sign in this expression, the negative sign indicates that the intensity decreases with respect to the thickness of medium. As the thickness of medium increases, the intensity goes on decreases. That means the light's energy is decreases in the form of intensity. Okay. Moving to next, as the ratio of decrease in intensity with the intensity is given by di upon I is equal to minus alpha dx. Di upon I is equal to minus alpha dx. On integrating and taking values from I0 to I, we get I is equal to I0 e raised to minus alpha x. That means we get the value of intensity in terms of the initial intensity with the exponential of that, the coefficient of absorption. Okay. Above equation indicates that the intensity decreases exponentially with distance in the medium. That means the equation shows that the intensity is decreases with the exponentially with the distance of medium. As distance goes on increasing, the intensity is decreases with the exponentially. Okay. Later on, see the summary. Now, what we have studied in this lecture is the importance of the laser. Other next, the brief history of laser. Next topic is ordinary light and laser. That means we have studied the difference between ordinary light and laser light on the basis of characteristics. Okay. Next, we have concluded that the characteristics of laser. Later on, we have seen that the interaction of radiation with matter, how the radiation interacts, then how the intensity light is decreased with exponentially we have seen. Now, the upcoming lecture we are going to study the energy levels of the radiated or of the matters or the of the matters, how it's deviated or how it's the matter gets the photon and goes to the excited level. Later on we will discuss about the population density. After that we can calculate the Boltzmann distribution. Okay. For that, before that, we will study the stimulated absorption and spontaneous emission and the stimulated emission. Okay, thank you.